Now, what happens is we're told that you throw it at an angle this time. And the angle we throw it at is 20 over 21. So ever see where I got 20 over 21 from? The angle, yeah? Would somebody be so kind as to calculate me the hypotenuse, please, using Pythagoras' theorem? So x squared equals 20 squared plus 21 squared. And then 29. Okay, so what we've now discussed is the fact that cos b is, what's cos b? 21 over, and what's sine b? 20 over 29, yeah? Grand. Anybody lost so far? Okay, you've just done that in trig recently, right? So that's all fresh in your mind. Now, here's what I'm after next, right? So, what I'm after next is the following. I'm told it's 58. Ever see 58? Now, this side here, it's the same angle. This side will be 58 cos b. And what is cos b? Because it's the adjacent, you use cos. And because this is the opposite, you use sine. Now, what is 58 multiplied by cos b? Anybody? 58 times 21 over 29? What? 42. Excellent. And what about the other one? It'll be 58 times 20 over 29. Huh? 40. Okay. Now, here's where this comes in, all right? What you know is that your initial velocity is 42I plus 40J. We all good with that? 42I plus 40J? Okay. Next thing. Let's make our 4 equations. So our 4 equations. Once we have the 4 equations, we can start. What's phi x? Anybody phi x? Always 42. What's phi y? 40 minus 9.8 t. 40 take away gravity times time. What's Sx? 40 t, yeah? No, not 40 t. 42 t, yeah? Yeah, probably heard you wrong. Sy? Yeah, ut plus a half at squared, half your gravity, t. Now you're going to do what you did in the question on the board. Now, so, phi y equals 0, 9.8 t equals 40, t equals 40 over 9.8, which I've been told is 200 over 49. Then I sub that into sy, so that's the answer for part 2, 200 over 49. And then sy is ut, so 40 times 200 over 49, minus 4.9 t squared. And what do you get for that? The greatest height. Huh? 4,000 over 49, thank you. Okay. Now, for the greatest height, because the throw is symmetrical, the time taken to reach the greatest height is actually the same as the time taken to come back down again. All right? So what can I do to find the total time it takes to land again? Double it. So I'm going to double that. 400 over 49, yeah? And what direction is the range in? Range is in the x direction, so we just do Sx. So Sx equals what? 2,400 over 7. Meters, yeah? Okay. I don't think I'm going to bother with the graph this time, but we'll show you how to get the points. Can everybody, using your calculator, do the following two functions? Can you do 42t and 40t minus 4.9t squared? So if you're entering them into your calculator in table mode, it will look something like this. You'll write f of x equals 42x. You'll write g of x is 40x minus 4.9x squared. I want you to start at 0. I want you to end at, for argument's sake, 15. And I want you to do a step of 1. Do you know what I mean by that? Do 0, 1, 2, 3, 4, 5, 6, 7, 8. Hey, what? So guys, what you get for the SX values? 0 what? To start off, 42. Oh, sorry. Yeah, no, be careful about that, guys. It's 0, 0. I guarantee you that the SX and SY at X value of 0 is 0, 0. Now what about X1? Yeah. Now, I could be lazy here because this is going to go up in 42s, isn't it? In a way, it wasn't necessary to do the SX formula, was it? We could just count up in 42s, couldn't we? Now, what about the SY? Yeah, next one. Next one. Next one. Finally on the way down. Do you see we're on our way down again? Okay, next one. Next one. So what's that? 290. 94 and what? 39.9. Next one. And yeah. Yeah, so you'd have to graph that. And what type of function would it look like? It'd be an N shaper, wouldn't it? It'd be an N shaper like that, if you drew it out. All right? We're not going to spend all day on